This next video is on exponential equations. I suppose another way of saying that is that you're solving equations involving indices. Let's have a look at the first one. We've got 2 to the power of x equals 32. So we could also say that 2 to the power of x equals 32 is 2 to the power of 5. X clearly equals 5. 3 to the power of x equals 1 on 27. 3 to the power of x equals 3 to the power of negative 3. Remember that 27 is 3 to the power of 3. If we bring that to the top there, to the numerator position, it becomes 3 to the power of negative 3. And there we get x equaling negative 3. Next one, 2 times 3 to the power of x equals 162. First thing we should do here is divide through by 2. And 162 divided by 2 is 81. 3 to the power of x equals 3 to the power of 4. Therefore x equals 4. Next one, 2 to the power of 1 minus x equals 16, which means that 2 to the power of 1 minus x equals 2 to the power of 4. We then get an equation whereby 1 minus x equals 4. X would therefore equal, if we take the x on the other side, we get positive x. Take the 4 onto this side, we get 1 minus 4. X equals negative 3. Next one, we've got 5, 25 and 625. So this is going to be an equation involving 5s because 25 is 5 squared and 625 is 5 to the power of 4. I mentioned on previous videos it's really important to recognise those powers of 5. So let's tidy up the left hand side here. We get 5 to the power of x times 5 squared to the power of 2x minus 3. And while we're at it here, we'll change the 625 to 5 to the power of 4. 5 to the power of x multiplied by 5 to the power of 4x minus 6, I'll remove those brackets there, equals 5 to the power of 4. What we're trying to aim to do here is get the base of 5 on either side, a 1 5 on the left and a 5 on the right. At the moment we've got 2 bases or 2 5s here. We want to get that down to 1, so we have to multiply these two together, and when we multiply with indices we add them. So we get 5x minus 6 equals 5 to the power of 4. But once we've got the 5 on either side there, we can now drop those 5s and it basically becomes 5x minus 6 equals 4. 5x equals 10, x equals 2 is our final answer there. Next one, 2x to the power of 2 to the power of x minus 16 multiplied by 2 to the power of x plus 4 equals 0. Now we can break that into two situations here. First of all, we get this, and from here we get this. Plus 4 equals 0. Let's work on the left hand side scenario first. 2 to the power of x equals 16. 2 to the power of x equals 2 to the power of 4. And therefore x equals 4. Over here, 2 to the power of x equals negative 4 by taking the positive 4 to the right hand side. Therefore, we have to look for a solution there, and there is no real solution to that. Okay, don't get caught up in saying it's negative 2 because it's not negative 2. 2 to the power of negative 2 is 1 over 4, not negative 4. Okay, so there's actually no real solution to this scenario here. Okay, so we actually only have the one solution here, and that's the x equals 4. Alright, next one. A tricky question. And a few moves need to be made here. Now, when we get the situation like this, and with that, it might vaguely remind you of a quadratic equation, which is something like this, okay, with a squared, a middle term, and a number. You might think, no, it doesn't really look that much like that. But if I make this first step, if I make this first step here, I can transform 3 to the power of 2x to 3 to the power of x squared. And just to digress for a moment, and I'll change pen colour here. These things are the same. 3 to the power of 2x, 3 squared to the power of x, and also 3x squared. Those things are the same. Might just move that over a bit so you can see it. Okay, those three things there are the same. Right, so please recognise that, because I've had to use that here in this situation, transforming the 3 to the power of 2x to 3 to the power of x squared, minus, I'm just going to leave the rest of it the same. Alright, now you might be thinking, well, I'm still not seeing this. What are you talking about there, Mr. Moore? Well, maybe now if we make a little substitution. And the substitution I'm going to make is I'm going to let a equal 3 to the power of x. Okay? If I do that, we get a squared minus 12a plus 27 equals 0. Okay, so see how I've made that substitution? Now you can see, yes, hey, this looks like a quadratic equation. Now I'm starting to see the light here. Right, so now we need to factorise this, and to factorise it, we get a minus 9, a plus 3 equals 9, and from there, that means that a equals 9 or a equals negative 3. Let's move on to the next slide. We'll take our working with us. Continue with this question. Alright, a equals 9 or a equals 3. Now, remember, a is 3 to the power of x. So we could now say that 3 to the power of x equals 9 or 3 to the power of x equals negative 3. Two things there. Alright, let's have a look. Sorry, I made a mistake back up further. Up here, that should be negative 3, which makes that a positive 3, which makes that a positive 3. Beg your pardon. Okay, so we're to here. Now we've got those two equations. Let's do them over on the right hand side here. Let's draw a line and we'll get going. So first one, we've got 3 to the power of x equals 9. 3 to the power of x equals 3 squared. X clearly equals 2. The other one, 3 to the power of x equals 3. And remembering that that is the same as 3 to the power of 1, therefore x clearly equals 1. There's our two solutions. We've got x equals 2 and x equals 1. Right, next one is a similar sort of question. But this time we've got the 4 and the 2. So if you caught on pretty well with the last one, this one might not be immediately recognisable. But we're going to have to do one little thing here. And if you remember, I equated something back over here. And I mentioned that these three things were the same. 3 to the power of 2x, 3 to the power of x squared, and 3 squared to the power of x, all the same thing. So please remember that now as we look at this question, because I'm going to make the 4 here 2 squared, like so, minus 2 to the power of x plus 3 plus 16 equals 0. Alright, now because all those things are equal, I'm going to change that to that. Okay, you can see how I've done that. Remembering the three things are equal. 2 to the power of 2x equals 2 squared to the power of x, and it's the same as 2 to the power of x squared, minus, okay, we've got 2 to the power of x plus 3. Now, second tricky bit of this question, I'm going to break this up in 2 to the power of x times 2 to the power of 3 plus 16 equals 0. Let's look at that conversion. That's a tricky bit. Right, let's look at that in isolation. 2 to the power of x plus 3. I can split that up into 2 to the power of x times 2 to the power of 3. Because if I go back the other way, remember, now when I multiply with the same base, I add the indices. So that's pretty crucial there. Alright, back to the question. I'm going to have to just order things slightly differently here. Now, we've got 2 cubed there times negative 2 to the power of x. I'm going to make that 2 cubed equals 8 times 2 to the power of x plus 16 equals 0. So I've made that 8, what I've circled there, okay, and put it out the front. Alright, now it's in quadratic form. Now the whole 4 lines there has been trying to get this in quadratic form. Because now I can let a equal 2 to the power of x. Okay, and we'll go over to the next slide now and continue. Alright, now if we let a equal 2 to the power of x, that means we get a squared minus 8a plus 16 equals 0. And now, that will of course be a minus 4 squared equals 0. Therefore, a equals 4. A equals 4. Now, remember a is 2 to the power of x. 2 to the power of x equals 4. 2 to the power of x equals 2 squared. Therefore, x equals 2. And we're done. So the last two really I focused on a bit there because those last two examples really are exam standard questions and ones you need to come to terms with. Alrighty. So that's enough examples there. I'd like you now to look at exercise 3C. And really there, I'd like you to focus with that one on questions 1 to 5 only, please. And exercise 3C, that's on page 140. That's all for now.